Good morning, sir. I am P. Lokesh Saikman from CSC section. Today I am explaining about separation of liquid mixture. Separation of liquid mixtures, techniques and applications. The separation of liquid mixture is a fundamental process in various scientific fields, ranging from chemistry and pharmaceuticals to environmental science and food processing. This presentation explores the essential techniques used to separate liquid mixture, highlighting their principles, applications, and real-world examples. Introduction to liquid mixtures. Liquid mixtures are combinations of two or more liquids that are physically blended together. They can be homogeneous or heterogeneous depending on the uniform distribution of components. Introduction to liquid mixtures. A liquid mixture is a combination of two or more liquids that are physically mixed but not chemically combined. These components retain their individual properties and can be separated by various physical methods. Homogeneous mixtures. Components are evenly distributed, resulting in a uniform appearance. For example, salt dissolved in water. Heterogeneous mixtures. Components are not evenly distributed, leading to distinct phases or layers. For example, soil and water. Miscible liquids. Liquid dissolve completely in each other, forming a single homogeneous solution. For example, water and ethanol. Immiscible liquids. Liquid do not mix and form separate layers. For example, oil and water. Principles of separation techniques. The separation of liquid mixture relies on exploiting the differences in physical and chemical properties of the components. These properties include boiling points, solubilities, densities, particle sizes, and of the for specific materials. Boiling point. The boiling point is the temperature at which a liquid changes to a gas. Different liquids have different boiling points. Distillation separates liquid based on their boiling points. Second one, solubility. Solubility is the ability of a substance to dissolve in another substance. Different substances have different solubilities. Extraction separates liquids based on their solubilities and different solvents. Third one, density. Density is the mass per unit volume of a substance. Different liquids have different densities. Centrifugation separates liquids based on their densities. Fourth one, particle size. Particle size is the diameter of the particles in a mixture. Filtration separates liquid based on the size of their particles. Distillation, separating volatile components. Distillation is the process that separates liquid based on their boiling points. The mixture is heated and the component with the lower boiling point vaporizes first. The vapor is then condensed back into a liquid and collected separately. Heating. The liquid mixture is heated, causing the component with the lower boiling point to vaporize. Condensation. The vapor is cooled and condensed back into a liquid. Collection. The condensed liquid is collected separately, resulting in a purified component. Extraction. Isolated specific components. Extraction is a process that separates a component from a mixture by dissolving it in a solvent that is immiscible with the original solvent. This technique relies on the difference in solubility of the component in the two solvents. Steps in extraction. First, the mixture is contacted with the solvent that is immiscible with the original solvent. Second, the desired component dissolved in the new solvent. Third, the two layers are separated. Fourth, the desired component is isolated from the new solvent. Applications. Extraction is used in various fields such as pharmaceutical industry to purify active ingredients, food industry to extract flavors and oils, environmental science to remove pollutants from water. Crystallization, purifying solute components. Crystallization is a process that separates a liquid solute from a liquid solution by forming crystals. The solution is cooled or evaporated, causing the solute's evolutivity to decrease, leading to the formation of solid crystals. Cooling. The solution is cooled, decreasing the solid's solubility. Crystallization. The solid begins to crystallize out of the solution. Separation. The crystals are separated from the remaining solution. Absorption, removing impurities. Absorption is a process that removes impurities from a liquid mixture by using a solid material called an absorbent. The absorbent has a high surface area and can attract and hold impurities onto its surface. Absorbent, activated carbon, silicon gel, zeolites. Applications: removing color, odor, and taste from water. Silica gel, drying liquids and gases. Zeolites, separating gases and removing heavy metals from water. Membrane filtration, selective separation. Membrane filtration separates liquid based on their particle size. A semi-permeable membrane with tiny pores allows smaller particles to pass through while blocking larger particles. Microtitration removes bacteria and other microorganisms. Ultra titration removes larger molecules like proteins and viruses. Nano filtration removes smaller molecules like salts and heavy metals. Reverse osmosis removes even the smallest dissolved molecules, producing highly pure water. Applications of separation of liquid mixture. Pharmaceutical industry. In pharmaceutical industry, purifying active ingredients and removing impurities. Food industry, extracting flavors, oils, and removing unwanted components. Environmental science, removing pollutants from water and air. Chemical industry, separating and purifying chemicals from various industrial processes. Water treatment, desalination and purification of drinking water. Thank you, sir, for giving this opportunity.